inside Alphabet X's new effort to combat climate change with seagrass. A previously unrevealed program would use cameras, computer vision, and machine learning to track the carbon stored in the biomass of the oceans. Bauman is a project manager for Tidal, whose team wants to use these cameras, along with computer vision and machine learning, to get a better understanding of life beneath the oceans. Now, MIT Technology Review can report, Tidal hopes its system can help preserve and restore the world's seagrass beds, accelerating efforts to harness the oceans to suck up and store away far more carbon dioxide. Tidal decided to focus initially on seagrass because it's a fast-growing plant that's particularly effective at absorbing carbon dioxide from shallow waters. But scientists have only a rudimentary understanding of how much carbon seagrass sequesters, and how big a role the plant plays in regulating the climate. Google launched what was then called Google X in early 2010, with a mandate to go after big, hard, even zany ideas that could produce the next Google. Humanity needs the oceans and is killing off the oceans, he adds. A better protein source. Tidal believed it could provide tools that would allow aquafarmers to monitor their fish in a more affordable way, spot signs of problems earlier, and optimize their processes to ensure better health and faster growth, at lower cost. But the computer vision software tags each fish with tiny colored boxes as it identifies individuals swimming through the frame, or captures them opening their mouths to feed. For instance, they might stop dropping food into the pen when the fish cease feeding. Restoring our coasts. The main possibility is that companies or governments could create market incentives to support preservation and restoration by awarding credits for the additional carbon that seagrass, mangroves, and salt marshes take up and store away. Diving in. Andy Stephen, a marine scientist with Australia's Commonwealth Scientific and Industrial Research Organisation, shows a seagrass sample excavated from meadows along Labuan Bajo, Indonesia. They collaborated on an earlier field trial off the coast of Fiji this summer and on the subsequent experiment this September in Indonesia. After a brainstorming whiteboard session, the Tidal team decided to take its own camera system, turn it face down, and put it on a float that could be pulled along by a boat. The system worked well enough during a few tests in a large pool in the middle of Alphabet's campus in Sunnyvale, California, where team members pulled it by hand over patches of plastic seagrass on the bottom. The bigger test, however, is whether Tidal can translate its maps into an accurate estimate of the carbon seagrass holds and buries in the seafloor. We've got it. Unlocking the secrets. CSIRO's Stephen says he hopes that Tidal's technology will provide easier ways to conduct the necessary studies.